Okay. Hello, everybody. I hope you can hear me well. I hope it's working with this stream. And I hope you can see me well as well. So, welcome to this first stream. So, as you can see here, I have a little agenda. But before I want to talk about what's the whole idea of this stream, that's actually going to be a series of streams. So, I want to show a bit some things about software engineering, how to build the reliable software, things that you can actually run in production and be confident that if something goes wrong, you know what's going right. And that goes way beyond just the normal, let's say, design patterns that you see in university and this kinds of stuff, but also goes a lot into like how you instrument your code, so you can measure like how long some bits of code are taking, like how long your database calls are taking, how many requests per minute or per second you're having, failure rate, and this kind of stuff. And of course, logging, right? How to instrument your application to have logs that can actually help you to very quickly understand what's going on. So the idea for today is to start a small project, a URL shortener. That's a very conceptually very simple project, but also that can be extended with lots and lots of fancy features. So we started this project, and then the idea is every stream we add some new features, or actually features, let's say, for our users, or then we add more features in this terms of like adding more reliability to the code, adding logging, adding more or better tests, or even just refactoring the code, right? And for today, the main idea is to get a very, very simple proof of concept up and running. So probably our data storage is going to be something in memory, very volatile, but we're going to have some endpoints working so you can actually register a URL to be shortened and you can actually access it. And then later we can go improving in all this stuff, right? A few things that like some like guidelines when designing and writing software, especially I think in Go, that's a bit more visible. So usually it's very important to focus on your problem rather than when you start from a small problem, right? Especially something simple like that. That I don't even know what kinds of features you're gonna have in the end. I just know that right now I want those two endpoints. Start it simple, keep it simple, and like Bill Kennedy said, don't get like all hung up on all the idioms. Those things come with time. So like, don't start a project with a gigantic structure of lots of folders and bits and bits that we don't even know if you're gonna need. Just start it simple and then go evolving to something bigger as you go, as you see the need of it, right? And as Rob Pike said, don't design with interfaces, discover them. So I'm gonna be really following those two kind of lines of thought today. So start something very simple, basically a main.co, put everything there, and then we go refactoring the code. And then at some point after a few streams, we're gonna have something bigger, more structured. But for today, let's put like the programmer's hat. It's also an idea from Bill Kennedy. Put the programmer's hat. You get the code working, then we put the engineer hat, and then start refactoring, shaping it, making it more testable, more extensible, and everything. So for the first, font's quite small, I've heard, and I have to increase that later. But yeah. Let me see if I see message on the chat. Yes. Okay. I'll try to zoom in. Give me a second. I think I just have to increase my font. That's something I didn't think would be an issue. Okay. Give me a second. Debugging issues live. If I increase the font of my Emacs, init, and then I hope maybe Now I need to reload it. And of course I don't remember how to do that on top of my head. So give me a second while I Google that. Next load file. Okay. X load file, not tile. And my MX is a bigger font. I hope everybody can see. If it's too small, please write in the chat. I think it should be real time enough to read that. Maybe we've increased it a bit more. Let's put 16 just to. And then load file. Ta, ta, ta. Oops, now I'm screwing up. 0. Okay, and then you have the file with the bigger font. Still even bigger than 18. Okay, let's go for 18. 18. File. 18. So hope everybody can read well. That probably is going to limit my ability to split the windows, but that's totally fine. We have the terminal. Also seems to be working fine and big enough. And let's go back to the agenda. Okay. So I hope now it's a good font size to everybody. And yeah, I think now we can start coding. So it's Go. Every Go program starts with a main.go. So create empty main.go pack file, package main, func main, and yeah, sometimes I struggle with my keyboard. And hello world, just to make sure everything's working. And go run go mod init github github.com, my Twitter handle that I still don't know how to pronounce. URL. I'll come up with a pronunciation of that at some point. Okay. And hello world printed. Okay, we have something up and running. So, okay, so let's start coding. We want to do a URL shortener. So basically, if you think there are two, let's say, big blocks we have here, we're gonna need, right? We're gonna need a HTTP server to run everything. And also we are gonna need a storage, right? To store some data. So I'll start with the storage for now, even though we're not gonna really be able to call the storage. Or maybe we can just write something simple in the main.go to test our storage. And then once we can put stuff in the storage and read stuff from the storage, we can start thinking about writing a HTTP handler to save something there. And then later we can get something and do all the redirects so we can actually call our URL and get redirected somewhere. And along the way, let's try to write some tests, right? So let's type store, or I'll just call storage DB. Let's go DB. It's a database of some type. To be very, very, very simple at the beginning, I'm gonna do a map of string to URL.url, right? So the idea being we have a key that's the shorter version of the URL, and then you're gonna map to a URL. I'm gonna use the URL.url. That's from the standard library. That's basically the type that supports pretty much every kind of URL, and then you can read it. My idea here of using the type URL is when you parse it from a string to a URL, it already parses, verifies to you that it's a valid URL. So this map is only gonna accept valid URLs, right? So that's one of the ideas. Go back. Okay, so we have untype. We need to create some functions. So if you think about simplest thing we could do, right? We're using like opaque type. So we're gonna always refer to it as db. Try not to open up the map, and later probably that's gonna be refactored something else. So we basically have two operations we need to do with this data store, right? We need to set some value on it, and we need to get some value. So my d, that's a db, and and no, set first, set. And set, I'm gonna need two arguments, a key that's a string and a value that is a URL dot not ULR. And I'm not gonna return anything. Okay, string, not string. Yeah, not gonna return anything right now. Probably should be careful with collisions as well at some point. Make sure we're not using the same shortener for the same thing. But for now, let's keep it simple. And also on my DB, I'll do a get and then a key string, and I get a URL dot URL as a response. So the compiler is going to be complaining that I don't have a return, so I'll just implement it. It's just a map. Okay, so set, that's going to be d of key equals a value, and that should work. And then the get, it's going to be even simpler, but return my d and key, and that should give us a data storage. So let's test it. Okay, we can parse URLs with URL.parse, so I can do URL1, URL.parse. I need to pass a string, let's say p dot colon / golang.org. That's also gonna return an error. If error is different than nil, then we need to handle this error. You should ideally never panic, but just for the sake of making sure things are working, I'm just gonna put some panics, and then because that's just test that. I could write a test for that, but sometimes usually just get something working. I write the test later. So, and that's just very simple. So let's do like that, and then I have a URL1. It parses, and now I need to store that. So I need a new store. So store, it's gonna be a db, and then we're gonna do is store dot set foo URL1. That should get it compiling. Compiler is complaining. That's actually a pointer to URL.url. So we need a pointer here. We need a pointer here, and we're gonna need a pointer here. Let's keep everything consistent with what URL.parse gives us. So that should allow us to run our program. That should just not panic, right? It doesn't panic. That's something good, right? If I do cut get to print ln, I got, and let's see. Oh wow, look at that. We have a super map. We have a map that works rapid on this beautiful DB type. Okay, so we can use that for something. So let's see what we do now. We can save and store URLs. We can get them. Should I write a test already? I'll write a test. Mom was afraid that I'm gonna take too long, but test or keep going. Well, I'll keep going. The HTTP tests are gonna be more interesting than that. So, okay, we have a store. It works, right? We know that we can use it, and now we want to wrap it on a, not wrap it, but have an HTTP handler and do the web server and everything. So so to start with, I'll probably I'm gonna start with the very, very simple. I could start with the HTTP handler package, the full HTTP package from Go. That would be an option because it already includes a very simple URL router, but it cannot route through methods, which making me think whether should I use that or a router already. But be honest, I'll just use the HTTP server from Go, and then we can do the things very simple, and then it get more complicated. So if I remember correctly, let's create our first handler. The HTTP handler can be a simple function. So let's see. I need to post endpoint. So let's call it save URL. I want it to be HTTP handler. So the signature is I'm going to receive an HTTP.response writer and a pointer to a HTTP.request. And close parentheses. And they did something wrong. Okay. So given that we have an HTTP, we can write an HTTP handler. We just created the empty functions for the save and for the get URL. We can get better names later. Right now I'm just thinking about getting the HTTP server up and running and just show that it works. So if we go and let's see if I can do it right. If you look at the documentation of the HTTP package, we have this function handle. That's a global function that's gonna add a HTTP handler and a pattern based on a URL using the default PoC. So we don't need to do anything, and then we just need to start a HTTP server. There is a listen and serve. Listen and serve function somewhere here. The server. Oopsie, not hijack. Listen serve. Should have an example that we can put our handler there. I'm trying to remember how to get the default MOOCs on the HTTP handler. Usually I use a router. And of course I'm trying to do something slightly different. Because otherwise what's the fun of doing live coding if you don't forget something, right? Listen and serve is, oh yeah, there's a listen serve. It's stupid me. Let's see how it goes. Handler. is gonna be my handler. That's not exactly what I want. I want to register the handler. And the func that open things in other tabs. Example. Yeah, okay. That's the what I'm going for. Okay, so let's keep things simple. We just need to do hp dot handle func, and then we pass the URL. So I'm gonna put say slash save, and then save URL. That needs to be typecasted because handler func accepts a function already. Should work. Yep, it works. And then we need another one, a func go. Let's use go. Let's go visit a URL. That's gonna be the get URL. Thank you, Emacs, for not doing autocomplete. And we do the HTTP listen and serve. HTTP dot listen and serve. Let's just listen on interfaces port 3000, and this nil here is the router. So basically, I have a dog that's getting noisy, of course. Okay. This last parameter here is actually the router. If you have a custom router, if you just pass nil, it's just gonna use the default router that those handle func are registering or functions. So, and then just make sure things are working. Let's do log. I have no idea how loud the dog is. I hope not. Yeah, try to do things live if you don't have a studio. We get those interesting things happening. So the standard library also has a log package. It's pretty simple. So I can do log.print ln and just print. I'll print the URL, that the whole request dot URL dot string should give me the full URL. And actually, I'm gonna do something like get URL and that one, and the dog's getting more quiet, hopefully. Okay, so that should be enough for us to have something up and running. And actually, another thing that's very nice to do. Okay, I'm back. I mean, I'm always here, just back with the mic. I'm starting HTTP server at port 3000. Okay, so a few interesting things to comment here, right? Oh my god, I didn't realize I didn't go back to my coding screen. Yay! So for that, I spent quite some time coding and not showing the screen. Yay. Let's screw up the first stream. Anyways, so let's go through what I did, and I'm not even sure when I stopped showing. So we created two very simple HTTP handlers that for now just gonna print something, so we make sure it's working, and then we start adding some code, and then decide how we're gonna pass parameters for that. So for writer HTTP handler, you need a function that receives a HTTP response writer and a pointer to a request. So I have two of them: save URL, get URL. as the name suggests, save is gonna save something in our data storage, and get is gonna actually do the redirect, right? And then we have the HTTP server here that starts the default HTTP server, and just a log line saying that, hey, the HTTP server is about to start. And actually, this one returns an error, so let's just panic on that. So this idea is like, if whenever this returns, it's gonna return an error, and it's just gonna panic, because right now we don't have how to stop the HTTP server, so it just stopped the whole program. And yeah, and then the pointer just prints something, so we know that we wrote the code that actually works, and then you can go move on different stuff. So okay, a few comments here. Configuration is a very important thing of any real application, right? You should never hard code values like that, like, oh, it's run on port 3000. Ideally, that should always be able to configure so we can run it everywhere. So if you look, if I get the buttons right, the 12 factor app on config, it says that an app's config is everything that's likely to vary between deploys, like staging, production, development environment, etc. And if you keep reading, it's gonna say that should be outside of the code base, right? Store configs in the environment. A very nice way to do that is read all your config, for example, for environment variables, or accept CLI parameters. Personally, I use environment variables. I think pretty much everywhere I work at for, we always use the environment variables. So that's very easy, and also you can provide defaults. So idea being, you provide some default values so the developer can run the application locally and goes on those well-known values that should be also very easy to see in the code base. And then when you get that code, ship it to staging, production, any other environment, you just need to set those environment variables in wherever environment you're running. If it's Kubernetes, you can use Kubernetes for that. If it's I don't know, running directly on bare metal or EC2 machines on AWS, you set environment variables there, and then it works. And the same thing in kind of environment. So you have your software, your code is independent of the environment they're running. It's also valid if, for example, if you're building Docker images, the configuration should not be inside the Docker image. You should be able, ideally, to get this exactly same image and run it in different environments. So you can actually get the same like artifact, the same thing we built, like the final result of building this application should be a Docker image. So get that the same image you can run locally for testing. You can run the same image in your CI/CD. You can run it staging. If everything's good, you can promote it to production. So exactly the same thing. As of now, I'm just hard coding it. I'll get to configuration very soon, as soon as we have something up and running. But for now, there's no requirement yet to make it. But that's far from be production ready code. We get there one day. And the same thing goes for the full handler and everything. I mean, the full HTTP server, it is production ready, but especially the functions for the features provided for the router are pretty simple. So most of the time, you're gonna actually need something different to add actually proper router. That probably gonna have time to do that today as well. So yeah, and port 3000. I usually run my application 3000. I like to avoid using 880 or 8000 because that's very common to many applications, and sometimes I'm just running something else on my computer, trying out something else, and they use those ports. So I usually try to avoid those kind of ports on my application, because if they're busy, then I don't get any issues. So let's see if you can run it. Go run. Okay, start on port 3000 and localhost column 3000 and get page not found. And then that what was get? No. If I can go back to my code, I did a register, save and go. it's empty, but it means that it's working. We got a 200. Let's see. Limit inspector. It is 200. Believe me. And go. It's also 200. Going back to the code. So that works. And then you also have the logs here. You can see save, go. Everything's working. So let's save something. I need to have actual a same data store for everything. So I'll create a type. I need a name for that. It's gonna be my handler. It's a struct struct type size struct. I'll have a db. It's gonna be called db. That's a very common thing in Golang to name things with the same name. For now, it doesn't need to be exported to anything, and that should be enough to allow me to do everything. So, and then comes the interesting thing. We actually need to be able to generate some random values. To random and unique values to actually save the URLs, right? And somehow return them at some point. And so let's see how we can do that. So to generate those random values, there are many different ways to do that. I'm for the beginning. Yes, I'm gonna just use a UID v4. There are many libraries in Go for that. This one's update. This one from Google should be fairly reliable. But the main ones, I'm just getting like the first one I found. Let's see the reference in Godot. New string, new ID, node interface. New string creates a new random ID and returns a string or panics. New string is equivalent to the expression. Okay, that should be enough for us. And then what we can do, we can return on the, we can write to our user that we have it. So did write the string there. So go get, and then if we go back to my Emacs, go get, and I'm screwed up. My terminal configuration is screwed up. Okay, go get, I have to type it. github.com/google/uid. Okay. So I should be able to, on the save URL, get a key. No, yeah, key. So what I'm doing is writing the save handler. So key is gonna ID that we got from Google dot new string, and should give us a UID before, right? And also we need to read somehow it. So the idea is that we can do a request. It's gonna be save, like /save char string URL equals my URL, like http ://golang.org, right? So I'm gonna have to read this URL bit. So let's see how we do that. So first I need my URL to save. I need a name for this variable. URL is the name of a package, so I cannot use URL. So value. I use v for short for value. On the request, you can access URL, and then you have the query, and then that's a function, and then you can do get, and then you pass a string URL. That is the thing you want. And this get's gonna return a single string. So have value, we have key. We need to refactor this code at some point. but let's focus on getting stuff working. Key value and you need actually to work on that handler. So H is a handler. So now that function is actually into my handler struct, and my main.go is gonna break. I'm gonna do that for the get as well. And here I'll have to instantiate everything. I'll do that in a second. Save URL. Okay. Just a log, and then what we can do, we can write on responser w.write. I need to write a slice of bytes. Okay. So let's do something msg fmt.s printf. So basically we use print to print on a string, and it's gonna be something very simple. Your new URL as, and then percentage s. And then we do w.write. I need to convert that to slash of byte and msg. And of course I haven't saved it. Then I can do let.db. I'm very curious what's gonna happen here. K equals value equals v. So actually that's a string, so I cannot do that yet. So we need to handle this error. Not even handle the error. We need to convert that to a parsed URL. Parsed URL and then error. That's gonna be URL dot parse and v. Right. So if error is different than nil, what we can do is, oops, yeah, Emacs. We can write an error for our user. So just never to forget to return when you're handling errors in your HTTP handlers. And let's just do a, there's a helper for that in the HTTP package. If not wrong error. No. Response error on the response. Right. There was a helper, remember. HTTP. Anyway, I'll just do it manually. Let's get a message. Msg fmt.s printf. And the idea here is we want to tell our user what went wrong, right? So we could not parse URL, so could not parse URL, and then I'm gonna use percentage q and put your so percentage q, it quotes this string for you, and also if you pass a slice of byte, it converts to a string, so it does some transformations. So it's very convenient when very quickly want to make sure something's properly like quoted or something. So I don't have to escape the quotes or use backticks, anything like that. Okay, we have a message we need to write for your user. So w.write header. So write header is gonna write you the status code. So let's use http.status request. And then we can write actually a message. That's gonna be byte and my MSG. And right? One very important thing, if you're writing like real applications that are gonna be open to the internet or to even users, let's say, that are outside your company, you want to be very, very careful with the error message you send, right? As you can see here, I'm not passing the value of the error to the user because sometimes this can actually leak lots of information about your application, or maybe it contains a secret or something that cannot be exposed. So be very, very careful. If you think that you can just return, like you could do something like put the arrow inside its error message, that's usually never a good practice unless you're very, very sure that there's nothing within that error message that could be a secret or something that's not be shared, or just give more information about your systems. Because if you think about something that's open to the internet, sometimes any kind of information of, like you'll say, oh, I'm using MySQL, there's a MySQL error, and then for some reason your MySQL is also exposed to the internet. That could be a vector for an attack. So be very careful. What we're gonna do here, we're gonna log the error message. So log print ln. So also on time, we're gonna put a proper logging library to have log levels and everything, but just error and percentage s. And post error. That should be enough. Should be enough. I'll do actually like that. So first we log the error, then we prepare the message, then write the message, and then we return. And then here we save the parsed URL. And it seems pretty good. And on get, let's not write get yet, right? So on main.go, what we need now, we need to instantiate your handler. So I'm just gonna call it h. The handler has a db field. Let's say new db, and that's columns equal. And here h dot h dot println. What's the error here? Print, and it's not println, it's printf, right? And we have a very simple handler. Let's go run. Our application starts. And if I switch back to my browser and I'll keep this one open, close the other tabs, localhost column 3000 slash save string URL equals http column slash golang.org. And then if I go back to our Emacs, we see that we saved it twice. I think I refreshed it by accident. But to save the URL, we get the message here. It says we saved the whole thing. And on our browser, we can see that we actually have the proper UID v4 here. Of course, we cannot access it yet because we haven't implemented. So let's implement something. And I just realized every time every time I press F5 on my browser, of course it refreshes. And that's also the shortcut I use to show my Emacs. So, okay. And it says save slash URL golang.org. Why? Save my log message. Where's my log message? Yeah, here. Save. Yeah, RURL.string. That's not what I want. I want to show what I've just saved. That is parsit URL. Go run main.go. If I go to my browser and I refresh, okay, you can see save your URL, the whole URL, and the thing. So if we try to send something that's not a valid URL, Let's see what happens. It's a mural. No, that's not valid. That should not be valid. A B. It's saving everything. Huh. That's not what we want. What could have gone wrong? If error is not nil, url.parse v. That's definitely not a valid URL. So one of the easiest ways to debug your code is printf debug. Print empty.printf printf n and just do r. What could possibly go wrong if I just want to write that nil? So Golang is parsing that as a valid URL. Thank you, Go. Let me try something else. HT column, column, golang.org. Okay, finally got something wrong. So yeah, the full definition of URL. Sometimes a bit tricky to break it. But yeah, we can see the error. We got our error log message, parse, valid port. If we go to the browser, we can see it could not parse this whole thing. It's just sending back the user's input. So that's pretty okay. And then we have a basic error handling. And also, probably not going to be so easy to see. We get a bad request for 100. Probably Chrome is not the best way to show that. But and if you go back to your coding, we have that. It works. Okay, I just didn't know how to break my own software. Okay, it seems to work. And let's implement the get endpoint. I'll keep the log line. So the get's very simple. We just need to return a redirect. If you go back to the HTTP, Golang HTTP, I remember that the HTTP package has also a helper to return a redirect, if I'm not wrong. Or there's another HTTP utu package. Might be an HTTP utu from the standard library. Reverse proxy, new chunk, buffer, server com. Nope. No. And let's just wake up. Oh. We have handle func, marks not found, parse HTTP version, parse time, service status, request the right, the response, type response writer, and the functor of the response writer. Anyway, you can just return a. No, there is a way to return a redirect easily. Let's do it. Go lang return redirect. Redirect over URL, Stack Overflow. They don't care about the cookies. Template, http.redirect. Hey, knew there was something. I didn't find it in the documentation. Of course, I closed the documentation. Smart me. http http.redirect. Yeah, didn't find because I didn't see it. It's here. So the redirect is gonna take care of making the. So this redirect function is gonna take care of making a proper setting the content type header and writing a valid like HTML body for redirect and everything like browsers and this kind of stuff need to do. So we don't need to worry about writing that ourselves. So just redirect response writer request URL that we want to redirect to and the code, the stats code. So the main stats codes for redirect, them especially like move it permanently and move it temporarily. It depends a bit on your application. I just use move it temporarily. Permanently can be cached for a long time because you say, okay, this resource is in a different place, like permanently. On a URL shortener, let's assume that's never permanent and keep it simple. So, okay, so we need to get our URL. So requested URL and the h.db.get. And the key, we need to read the key. So the same thing as we did with the save, we're gonna have save, so I have gonna go, and we can do go and do. We can use do, so we can have something like slash go do and the IDV4. We could use a URL parameter or something. Probably later when you put a proper router, we go for a URL parameter. But the full behind the full router doesn't allow us to get it directly. We have to parse the whole URL. So I'm gonna avoid this thing now. And okay, no, Tiago, that's not what you want to do. What you want to do is to get the URL, the UID, and then go. So and then I have my key. Gonna be r dot URL dot yeah query dot get go. And one thing, like those parameters, like go like wait. Oh, what did I do here? Sometimes I get confused with my own keyboard. I changed it not so long ago. A different keyboard. The keys are slightly different. Haven't relearned it fully how to type. Anyways, so usually things like carry string values and things like that when actually writing final applications. Unless there is a really good reason, I tend just to hard code them because they're very tight to the rest of the code that's here. So they're never gonna change unless you actually change the code for some reason. So I just usually have them hard coded. And then of course ideally you write some comments about your handler and then you say, hey, those are the accepted parameters, or even you document your whole API and there you list them. And then here you can just have them hard coded. Usually there's no harm on that. You have my key, so I have my, now we can get a requested, or I want to make like a go to, but go where to requested URL. Requested URL is going to be h.db.get key. And now it's written Harvard. Interesting thing, our storage doesn't tell us if the key is not there. So for now, let's see our storage what it does. It just the get just returns a URL. So yeah. So because it's a pointer, because it's a mapping go, if I don't have a value there, I'm gonna should get a nil. So if requested URL equals nil, I'm gonna return a not found. That should be a helper as well. Not found. That just gonna not found. No. I was just gonna return not found. Yeah. Not forget HTTP dot not found. No, that's a handler. No. Not found reply to the request. HTTP error. Page not found. Okay. WR and return. Never forget to return. And if then it works, then we can do a redirect. HTTP dot redirect response writer. We need our request. We need a URL. That's a requested URL. Requested URL. No Emacs. Requested URL. It dot string and the code hp dot status temporary redirect. That happens to be 307. And then we log get key value key and requested URL dot string. Right now I don't even care about performance if I'm converting the URL 10,000 times to string. We just want to get something up and running that say, hey, we can go somewhere. And hopefully that should work. And there's only one way to know. I mean, there are two ways to know. You can write test or you can run it. I'll run it. Usually most of the time I actually write the code, I test it somehow, like running, and then I go back and write tests. I mean, test-driven development is another option. Never really got the time to deeply study that. So most of the time I'm just testing manually, then I go back, write tests. Depending on what I'm doing, sometimes something bigger or it's a piece of a bigger application that already exists that's very hard to test on its own, then I write code, a bit of testing, so I can test that independent piece without having to hack around with the whole application. But that here is so simple. You can get something working, then you're happy it works, yay, and then you go write your tests. Okay, so let's save http online.org. Your new URL is, so it's saved. So it should be local. Go to my UID v4 and page not found. Beautiful. The URL saved. We got page not found. Why? Then we did more logs. I mean, logging is something that I want to take some time later to really go through logging, how to do it and everything. But that's, for example, that's the thing you can do. You can use like different log levels. Like for example, that's a debug. I can log everything, all my parameters and things like that. So go to, let's see. First thing I'm gonna do, I'm just gonna log something here. Print lien and say get URL. Idea being is if for some reason I wrote the wrong URL, I'm not getting the handler. So this first log is gonna tell me, hey, you went to the handler. Right? That's not something I'll leave here for too long, just for debugging. And then actually can I add here actually no, I'll do that. And then on another log line, right after log dot print n, and I'll do value, and then you can go to key. and then we can run it again. So if we go back to the browser, we can save URL and we can try to read it. And if I did everything right, I get a page not found, and I go back to Emacs and I see, okay, the handler started and the value is not there. Why? Because I wrote wrong key string. Go is go to. Yes. So that's more change. Run. Let's go back to the browser. Save something. Get our new value. Let's quickly look at the Emacs. Yes, we're saving with many different ones. Go back to the browser. Get the latest one without the empty space at the beginning. And ta-da! It works. And if I use my shortcuts right, you see get URL, the value, and the final log for it. So we have something that actually works. So let's remove those print debugs. I removed something I shouldn't have. Yeah, go to let's just, for the sake of it, let's run it again. Get a new one. And then I'm doing the request again. So you can see the terminal that, okay, everything is working and my browser worked. Probably should organize to have a split screen. So I don't need this log line anymore. I don't need this log line anymore. I can keep that, and let's test the 404 case. So if I go back, okay, let's make sure it's running. So let's test the 404 case. If I go to my browser and I go to something that doesn't exist, I get 404s, and that's good. If I save URL and get URL, so checking again, getting 404s, and then I go somewhere. So let's go back to Emacs. So, and here we have something that actually works. Right, we have our handler. We have two handlers. We have some logging. Very basic, but we do have it. And then we have a very, very, very simple main.go. That's all we need to start executing and running. So let's just do a bit of cleanup here. Arrow, I'm logging the arrow. Here I have an arrow that I'm not logging. In this case, I'm not gonna log the reason for the 404, at least not right now. I don't think so necessary. What I'm gonna do is to make sure that like at the end of the handler, both handlers keep it consistent. I have a log line just to know that it's working, and it was after doing everything, so I know at least my handler run, right? And we have that, and it has been about 1 hour. I don't want this stream to go too long, not much more than an hour and a half or so. So I think for today, I'll just add a config, as I mentioned that, because that's very, very quick. So for config, there are many, many ways of reading configurations, right? As I mentioned, environment variables is one that I use it a lot. I like it. You can define defaults for that, and it just works, right? There are many ways. You can just read it by yourself. Golang provides functions to read it, or you can use an external library. There are a few libraries for that. There is one very simple one that that's this one here. I like it a lot. It's pretty simple. It's still in active development. It has a very simple syntax. Use like build extract tags on a struct to say which environment variable you can use at the full, right? And you just call parse, pass the pointer to your struct, and it does everything for you. It can pass many types already, and you can even parse your custom functions. I don't remember required fields. Yeah, we can have required fields now. We have required fields, so we can say, okay, this field is required. So if you don't set it, you get an error when parsing. So that's the one I'm gonna get. I could just write one function to actually read the environment variables and have a default. But on this one, I'm just gonna jump straight for the library because it allows us to actually write the config struct and everything. It's that already a bit more organized than if we write our own function that at some point we're gonna want to have a struct for that. So okay, go get github.com carlo 0/0/env /v6. Okay, type config, and the type config is a struct, right? So the idea is inside the struct you're gonna put all the configuration for our application, so that in time it can be a gigantic struct, right? The way I like nowadays to do it is I keep this struct in the main.co file, right, where the application starts. And the struct is unexported, of course, and nowhere else in the application you know about this struct. The idea being is all your modules, everything that you're writing should receive directly the parameters they need, right? So let's say you write a database abstraction that's going to connect to a Postgres or to a MySQL or something like that. It shouldn't need to know about a config type, right? A global configuration where it can read the value for itself. It should say, okay, it has a new function, a constructor, and the constructor should receive all the parameters you need. If it's external library, the external library might even provide you a config struct that you populate and just pass a struct to something. But inside the application that I'm writing, I always keep the configuration in the main.co, and then I pass just the values itself to any function, any constructor, anything. So that also helps later on testing, because then you don't need to have access or build a config structure. Just give the values that your function, your type, the module you're initializing need. And also like configuration is not a feature, right? Like in the past, I even wrote some application that had a config package with a config struct and pretty much that. And then just use that in the main.co. Sometimes it has a new function that compares the environment variables for you. But then later talking to some other people, someone told me like, yeah, but if you think about it, configuration is not a feature, right? It shouldn't need its own package. You can just have it on the main.co, and your whole application doesn't depend on this config struct. And also, for some reason, you totally change the way you do configuration, and that old package is not required anymore. You don't need to refactor whole code. Just the main.co knows how to get the configuration and pass it. So, okay, so let's do a simple port configuration. It's an integer. And another thing that I really like about, let's go back to code. Using, not really using libraries, but that I recommend when parsing configurations, use the right type. If you get like a HTTP port, if it's just the port, it's an integer, it's a number. If you want the whole address, then that's a different story, right? If you want to do time, please use time iteration. Don't use an integer that's a number of seconds or milliseconds, then you have to multiply for something. That can easily be misunderstood for some reason, and then you can end up with wrong values. Because like if you just have like let's say a duration or a timeout, and then your environment variable is called timeout, right? Uh, and then okay, how do I put values there? Golang has this beautiful time dot duration that you can parse, and then you can pass seconds, milliseconds, hours with prefix, super well documented. So if you need to get time, do use time duration. Don't use an integer and convert to seconds and go multiplying. That can be very dangerous. I actually had a problem once. I was refactoring a very old application that read the timeout for the HTTP server as an integer. And I refactored it to read as a time duration. Right? That was pretty good. And that somewhere in the code, there was still multiplying that for a big number. For like the time for, I think it read in milliseconds, converted to seconds, something like that. And things got broken because we had a weird timeout there. So if since the beginning, if it's timeout, time duration, if it's a number, the proper number, same thing for booleans and everything. Really try to use the type safety of Golang to help you in everything you're doing. So port int, and it's gonna be p. I could also just call port, but let's be more specific here, and need to port. Eh, port that's quoted, and then I provide the env full. That's gonna be 3000. So what does that mean? That means that if I export environment variable a port, then I'm going to be able to read and use it. If I don't have the environment variable HTTP port defined when I read, I get the 3000 as a default value. So main.go cfg is a config, and then we need to do if error different than new error column equals env dot parse, and that env is that library there I already started, and it receives the pointer to my cfg, and that's it. New it's complaining about something if add import. If error is different than new, I'm just gonna panic. But I'm gonna panic with a nice message. Printf. I think this printf cannot parse the configuration. Percentage s, and then I'll pass error. If not out completing Emacs, I thought there's something. Yes. So, I mean, we all know you should avoid panic as much as possible, but that's like the main.co. I'm reading my configuration. If there's something wrong, it doesn't make sense to start the application. So just panic, and that's it. And of course, we need to use that, right? Starting HTTP server at port presentation D because it's a number, cfg dot port 20 value, and here I'll do t as printf column percentage and okay, if I do if I, what did I do something that I didn't want to. If I go to my terminal, go run And that's a trick I kind of I forgot to mention at the beginning. You can do go run main.go, like your file, and that already complaining. But you can just do go run dot, and the go-to is gonna find the main.go in the right file for you. No required module provides the package because it's v6 of the package, and probably my go import didn't manage to get v6. V6. Go run. I screw up something. Listen local. Yeah, panic on TCP. I probably screwed up the string somewhere. Yes. Even my cfg.port. It's not a print ln anymore. It's a print f. That's at port 3000, and let's see if we do http port equals 7000. So you can just on in Unix system like Linux, Mac. I have no idea about Windows. You can just prefix your commands with an environment variable, and then the command receives that environment variable. So you don't need to export in your whole shell, and you can easily replace it for different iterations, different times you run the application. And now it's running on 7000. Okay, so let's go to the browser. Let's see if I can do that on port 7000. And seems that it works. And if you get that, and it do, oh, not on capital letters, Tiago, not save, go, question mark, to that one, and there's something wrong. Go to, it can be reached because it's not 3000, it's 7000, and it works. So if you get back to your Emacs, I saved the URL multiple times, got the URL, everything works, and we have a happy application. So, and that's it. We have a POC. We have a proof of concept. We can save URL. We can visit them, and it works, right? We can configure our application. So if I compile that and ship somewhere, I can run in any HTTP port I might need, right? So that's a nice thing to go. We have a very, very, very minimum of logging to know what's going on. So we know in which port the HTTP server is starting. That's something very nice. That's also something that's good to think about when you have production, like really think about writing applications. Is it's nice when the application can tell you, oh, I started on this port, instead of assuming that you're gonna know, you know, because maybe you misconfigured something and then you just trying to test your application the wrong port and get 404. And if you're just running locally, that's easy. But if it gets deployed somewhere, and then the configuration is not there, then like, why is my application not working on production or in testing or in the QA environment? And then you can just look at the logs. Oh yeah, the application told me it started port X. I was trying port Y, and that doesn't work. So that's it for today. Let's look at our agenda. I don't have it open anymore. We have it, we have edit storage, we have a get endpoint, we have a post endpoint, and we even did a bit of configuration. So thank you everybody for watching. I hope it was insightful, interesting. I hope you could learn something. And that's gonna be it for today. I'm gonna put the whole code on GitHub. So let me go here. I already create a repo. I'll send in the chat. And for now, I just have the license. Every stream, I'm gonna add a short description, maybe like a changelog or something. Haven't said it yet, how to do it. But definitely, like as soon as I end the stream, I'm gonna commit the code and push it to GitHub. And then in the next streams, we start exactly where we stopped. And then we see how we go evolving. So I hope you all liked it, and see you next time.